Hello, and welcome to this video from BitifEye. My name is David Baus, and I'm here with my colleague, Christian. Today, we're diving into one of the more challenging aspects of validating the PCI Express physical layer, specifically the electrical layer and receiver testing. As the standards have evolved from PCIe 5, which runs at 32 gigatransfers per second with NRZ signaling or two-level signaling, now to PAM4 signaling for PCI Express 6.0, which is four-level signaling. A particular aspect of testing has gotten increasingly more complex, and we call this the back-channel optimization. So we have a fundamental challenge when testing receivers. You can send a stress signal to the receiver, but we need some way to indicate what the performance is. How do we know the receiver performance since the output, a digitized bit stream, is within the silicon chip? So there's two main categories to address this challenge. One of those is through on-silicon analysis. Maybe that's, let's say, an error counter or something similar. The other one, which we'll focus on today, utilizes a mode called loopback. And that means we're sending a stress signal to the receiver, digitizing that signal, and then in loopback mode, we retransmit the stream of bits out of the device's transmitter. Then we analyze with some test equipment, as we have with us here. As we've moved to these higher speeds with multi-level modulation, the path that the signal now has to take from the device's transmitter back to the test equipment, which we call the back channel, has become a particular challenge because we need to ensure that we're not introducing errors in the signal path. And that's the topic for today. Christian, can you explain to us the various components of the back channel at a high level? And ideally, how do they work together to ensure we're not introducing errors at the error detector of the BERT?
Sure. The back channel contains all elements starting at the DUT up to the BERT receiver. That includes obvious parts like the PCB traces, connectors, cables, and redrivers if present. But also things like bonding wires inside the DUT and BERT, as well as the FFE and the ADC inside the BERT. To get the lowest bit error rate in the back channel, it's crucial to adjust all parts together for the given setup. The DUT must send the best preset, the redriver must be set correctly, the FFE tabs need to be adjusted, and the sampling setup consisting of sampling delay, input range, and threshold has to be fine-tuned.
Thanks for the clarification. So another question, how does the BitifEye ValiFrame software coordinate the equalization of the redriver with, let's say, the equalization schemes that are in the error detector in the BERT? How does that all kind of work together?
Yes. The redriver optimization is actually the first part of the back channel optimization. And the settings are kept the same for all presets. The differences between the presets are compensated with the FFE of the BERT. As I just hinted, it's possible to optimize the BERT for every 64G preset, which is necessary for the LEQ-TX test, where we have to be able to train the DUT into loopback for every preset. For the LEQ-RX test, however, where only one as good as possible setting is necessary, we highlight the best preset in green and set the value automatically for the test. So the engineer doesn't need to change anything. Of course, it's also possible to optimize the BERT for only a few or even just one 64G preset.
That's fascinating. I can see why one would need automation for this. So I have another question for you. In terms of isolating the errors, the error could occur either at the receiver under test or in the back channel. And how does one even come to know where the various errors are occurring and understand the difference?
That's a really good question. To make sure we are only capturing errors in the back channel, we let the DUT transmit a known pattern. By default, we toggle the DUT into the correct PCIe TX compliance pattern, fully automated. If we are able to optimize the backchannel at least 2 decades better than the required BER for the RX test with the selected DOT TX preset, we can be confident enough that errors observed during the RX test are occurring in the RX under test and not in the backchannel. By the way, if you run into problems with toggling or with the compliance pattern, you can also set up ValiFrame to expect any other pattern, for example a PRBS 23 pattern.
Thanks for clearing that up for me. So, Christian, would you mind walking me through a typical workflow and kind of showing how the new ValiFrame software from BitifEye does the backchannel optimization? What does that look like? What are the various steps?
Sure, let's switch to the setup. The backchannel optimization is a standard procedure located under the setup preparation node. To keep it short, let's just optimize Q0 and necessary 32G preset P4, which will give us a good starting point when we switch to 64G. As already mentioned, the first step is measuring the estimated backchannel loss and applying that data. Next, we run a FFE optimization for all 32G presets. In this case, only for P4. This gives us a good starting point. Now we run the FFE optimization again, but this time for the first 64G preset. Then we run the sampling setup fine optimization for the same 64G preset. The sampling setup is the combination of sampling delay, input range and thresholds. After the sampling setup is finished, we would continue with the FFE optimization for the next 64G preset. But since we have only one 64G preset selected, we are already finished with the whole procedure.
Well, thanks for the demo. So if I understand it correctly, that was for a single TXEQ preset.
Correct.
How long would it take to run for all of the TXEQ presets? And how often would an engineer need to rerun this procedure?
Of course. It always depends on how fast the algorithm converges to a good enough solution. However, normally it takes less than 30 minutes, even for a 27.5 dB channel. The optimization finished in less than 40 minutes. To answer the second part of your question, I need to quickly introduce the realignment. The realignment is a quick backchannel optimization that takes approximately 5 seconds per preset. It is done before a test to adjust for slight shifts, since the full backchannel optimization was run and is done only for the presets used in the test. If this realignment doesn't find a similarly good backchannel optimization as the full backchannel optimization, that's when you should rerun the backchannel optimization.
Thank you very much, Christian. So as you've seen from today's demonstration, BitifEye has a solution to automate the backchannel for receiver testing up to PCI Express 6.0 devices. This takes away a lot of the complexity and a lot of the time, and you can have more confidence in the receiver results that are provided in the end. But of course, this is a new category of problems that we'll continue to face as the standards evolve. So the PCISIG is currently putting the finishing touches on the 7.0 base specification, which will bring 128 gigatransfers per second, also with PAM4 signaling. And of course, these challenges will persist. New solutions in terms of hardware, software, automation software will need to be developed. So we'll continue to bring expertise, innovation into this area to make your life as simple as possible for the validation teams and everyone else working with you. We hope this gave you helpful insights, and we look forward to supporting your projects in the future. Until later, see you next time.